Hey everyone, so I'm going to be demonstrating GeoGebra today, which is a very useful and versatile mathematics program available for almost any platform. It's available for Windows, Mac OS, Linux, Windows Mobile, Android, and iPad. And there's also a web app that you can use just by going to geogebra.org and launching the web app. So after you have installed it, so you would go to geogebra.org and download if you want to download your program, or you can use the web app. And then once you have installed it and opened it, it will look like this. I am using this on a Mac, so that's why the controls are Mac appropriate. So I'm just going to start with an overview. Um, this is kind of your home base, and you're going to have the default view has the algebra window on the left, which is part of the CAS, the computer algebra system that the program includes. You also have a graphics view that acts as a two-dimensional Cartesian plane. You have an input bar down here for functions and such like that. You also have these control buttons at the top. And I should probably extend my view. But basically, you have up at the very top, you still have other Mac-specific controls, like your GeoGebra button, File, Edit, View, Options, Window, things like that. So you have all of those buttons as well, which are off the screen that I'm recording right now. So anyway, the basic operation of GeoGebra consists of everything from basic math all the way up through calculus functions. I've even used some of the built-in functions, such as a slope field is really useful if you need to draw a slope field, and you can create some really beautiful things like that, all using this free program. So it's really great that they've expanded the functionality of it to more than just geometry, which is where it started. So one of the other great things about this is that there are no ads. It's completely open source software, and I'm a big proponent of the of open source software and the Free Software Foundation and things like that. So it's really nice that all the coding is open source, and if you're a programmer and interested in contributing to the project, you can look at all the source code and email the developers if you think you have a way of programming a function or feature better than it already is. It's also very user-friendly and very scalable based on what you're trying to accomplish with your class. You can do everything from basic math to lots of applications in Algebra 1 and graphing, learning about quadratic functions and other types of functions. And then you can also use the CAS functionality to investigate other algebra topics. And then obviously there's a lot to do with geometry, as its namesake would imply. So you can use this in many ways in geometry for constructions or teaching other topics. So we're just going to start with some basic functions that I have found very useful and informative. So I like this view. I typically will come in and if you right click, you can add a grid. If you're trying to do something in geometry, that can be very helpful, or in algebra if you're trying to look at specific points for things. So I'm going to use this to demonstrate first some basic graphing of linear and quadratic functions. So we could come down here to the input bar and type, y equals x, or we could also type f of x equals x if we want just the line right there. We might also want to investigate f of x equals x squared. I don't know, x squared minus 2x plus 3, and then we get a quadratic there. We can look at, we can also take this and use our move, and we can drag this around if we want to drag it around. And notice up in the top left corner where it's showing the function, it's actually updating the function as I'm moving it around in parametric view, and then, or parametric form, excuse me, and then it'll actually snap two whole integers on the plane, assuming that I'm trying to line it up with a specific integer here. So I'm trying to do it slowly enough that you see it. So if I'm looking at the vertex here. So as I'm approaching the vertex or the point 4, -1, it kind of snaps to it, which makes it really easy to line something up if you are interested in that. And I can just drag this algebra window out farther if I want to see more of my function, and it resizes the graphics window appropriately. So that's just a very basic explanation of how to plot a function. We may also want to investigate something more geometric. So we can just, if we want to close that, I can just select that and delete it using the delete button on my Mac. Say, for example, I want to draw a polygon. I can click here and it just automatically defaults to polygon. I can also do a regular polygon if I'm interested in that. So say I'm just going to teach some basic shapes. I can do regular polygon. The icon changes and it tells me, if I just let my mouse hover over the button, it tells me that I need to select 2 points and then enter the number of vertices. Of course, if this is a regular polygon, all of the sides and angles are going to be congruent. So all I need to do is specify one side length, which is defined by 2 points, and then enter the number of vertices, and it just copies that all the way around to create the polygon. So let's say I'm interested in octagons for whatever reason, and so I select a point here, and I'm just dragging this. I'm not clicking the mouse down, so I just click once. It knows that I'm creating a side, so I can just drag wherever I want, and it'll kind of snap to integer points again. So say I want to choose the point 6, 7 right there, and then I just click again, and it sets the other point down and then asks me for the number of vertices. So if I'm doing an octagon, I would need 8 vertices. I click OK, and it creates my octagon. That's kind of gone off the screen here, so if I go back to my move button up here on the left, I can move, and then I'm just clicking and dragging. I'm clicking and dragging the screen, and so then I can just resize it wherever I want it to be. And then I can move the actual octagon also if I decided that I want it bigger or smaller for whatever reason. So I can find the exact octagon that I want, and then that might be a little bit easier there. So, and then I can perform constructions or other things off of it. Say, for example, I might want to show that my students that I can draw a line through opposite vertices here, okay? Or I can draw another line through here. I'm just using the line button, which is up there. If I just click line, okay? I could also do segments if I want to do segments. That's in this little drop-down caret. So I can do all kinds of things. Might create a line through there, and I can also show them that if I'm connecting opposite vertices, then they all intersect at the center of the figure. So I'm just going to go to View. I'm going to go to Algebra here, so I can see this again. Now this is showing me all the different components I have on my screen now. So I've constructed 4 lines. I constructed 2 points, A and B, which were the original points that I had for the construction. And I have a polygon, and then I have a segment that was in between the 2 original points. And as I'm rolling my mouse over these, I'm just rolling my mouse and hovering, it's going to highlight the actual things that I'm hovering over. So if I'm hovering over that, notice that point A is highlighted now, and here point B is highlighted. Say I want to label these things. Well, I can actually right-click, Show Label. It'll show me that that's polygon 1. Or say I want to show label on the points that I've labeled, and then I can go back and show this label if I want to show that one, and right-click, Show Label, and go around and do whatever I like. I can also hide things from the view, the graphics view. Say I want to get rid of these lines. I can just click the blue button over here in the algebra view, and then I can just hide those things. Or I can bring them back later, one at a time, or two of them, or however I want to do it. I might want to show my students that that creates a perpendicular line there, which I could do with this angle button, and select here, and select there, and then it shows me that I have an angle of 90 degrees. So I could do that. I mean, the nice thing about GeoGebra is that it will do pretty much anything you want it to do, and it's free and it's easy to use, and there's not any programming that you have to learn or commands that you have to learn like Mathematica or Maple or one of those kind of really high-powered ones. Now, of course, this will not do all of the higher order calculations that Mathematica or Maple will do, but for secondary mathematics, this is very useful and very, very easy to learn for students. So I rely on it a lot. I can also create demonstrations that I can use on my iPad through the iPad app, and then I can show that on a screen in my classroom if I'm trying to demonstrate a geometric property that is easier than drawing it on the board or trying to illustrate something in a static way. I can create a very dynamic demonstration or model on GeoGebra and then explain things like that. Actually, let me show you something really quickly that might be helpful to explain this. If I'm going to go to a new window here. Okay, so here's a new window. Say I am teaching circles, okay? I don't really need the axes. I can turn those off. Well, I can create a circle with a center through the point. Say I'm interested in say that I'm interested in teaching something about circles. So I can create my center and drag out till I find the circle that I want to describe. There's the circle. And so then I can create, maybe create a segment from here to show what a radius is. I can create another point on the object. I can create a point right there that's on the circle, and I can create another another segment here to here. I don't want to really show the label of the circle. I don't really need that. And I can create an angle maybe between this and this. So there's my angle right there, and I can show as I'm going around. Let's say I want to demonstrate inscribed angles. Let's do that. So inscribed angles. I need another point somewhere over here. I can create more segments from there to there and there to there. And I don't really need all these segments labeled because I'm not showing anything about the segments. I'm showing something about the angle, so I can just take all the labels off to make it nicer. On the angle, I'm going to go to Object Properties and say I just want it to show the value, so I can get rid of that alpha. So there's my value. Oops. Wait, edit, undo, Command Z. Always Command Z if you mess up. And then I can go back to my angle button, create an angle from here to here, and now I've got to move this out here, and I can go to my beta, Object Properties, Basic, and just show the value. Okay, so now I've got the angles of there, and then I can just move. I can go back to my move. Say I move this point. It's going to resize, okay? It's going to resize, and this is a really nice way of showing the students that whatever the size of the circle, it doesn't matter, and then whatever angle I set this at, the central angle is always going to be twice the measure of the inscribed angle. And they can come play around with this too and show them, oh, if I move this, that always stays the same. It's always 60 degrees. If I change one of the endpoints, it's always going to keep that 2-to-1 ratio. So that's a lot easier to show and a lot more engaging for the students to show that on something like GeoGebra that's dynamic rather than trying to draw it on the board and explain it on even a smart board, because it's just easier to show when you have a dynamic model like this that you can play around with, and the students can even create this on their own computers if you have a computer lab or something, and then everybody can do this and kind of experience the understanding from the point of a construction. So that's about all I'm going to talk about with GeoGebra. Hope you've enjoyed it. Thanks very much. Bye.